So, this is the second part of DRG6. The first part of DRG6 was isometric projection. Isometric projection are 3D pictorial views at an angle of 30 degrees by 30 degrees. Now, the second part of DRG6 is orthographic projection. The reason they are both DRG6 and not isometric is DRG6 and orthographic is DRG7 is because they are both gonna come together. So, what is orthographic projection? Orthographic projection is a means through which three-dimensional objects, so 3D diagrams, are represented through 2D pictorials. So, orthographic projection is a way of looking at 3D diagrams through 2D diagrams. I'm going to show you what I mean. So, let's say we have this 3D diagram, right? These steps. These are in isometric projection. How do I know? Because it's 30 degrees by 30 degrees. Okay? And it can be clearly seen that it is a 3D diagram. Now, let's say we have this isometric drawing and we need to apply orthographic projection to it. Now, with orthographic projection, we have three 2D views. What do I mean? Now, orthographic projection, we have two types. We have what we call first angle projection, and we have what we call third angle projection. But first, before I go into those, I'm just going to explain something simple. Like I said, with orthographic projection, we have three 2D views of one 3D diagram. So, orthographic projection, we have three 2D views of one 3D diagram. We have what we call the front view, which is looking from this side. Imagine front view. You're standing over here, and you would draw what you would see when you're looking from over here. What you would see would be this, and this. Then we'd have another view called the end view or the side view. The end view is what you see when you're standing from over here. So what you would see from here, and what you would see is this part, is this diagram. Just this. Okay? And we also have the plan, which is when you're standing from up here and what you can see looking down. So what you would see are this, and this. Okay? So those are the three 2D views when looking upon a 3D diagram. That's it. Don't think about it too much. Don't complicate it too much. That's all it is. Orthographic projection is the breakdown of a 3D diagram into 2D views. Now, we have a rule of how to draw these diagrams, which is where we break down into first angle projection and where we break down into third angle projection. With the first angle projection, we draw the front view over here, the end view next to it, and the plan underneath the front view. Now, what is this line? This line is a 45-degree mitre line. What it means is, for example, to create the plan, to draw the lines, all you'd have to do is drop lines from the end view and take them like this, and drop lines from the front view vertically. The mitre line, the 45-degree mitre line, is just there to help you. It has absolutely no other purpose. Now this line, it's important to remember, is always 45 degrees. Okay? So this is the first angle projection. Here we have the third angle projection. Third angle projection, we have the front view over here, the end view over here, and the plan over here, and the mitre line, which is still always 45 degrees over here. Okay? So the diagrams are going to be exactly the same. So if we have the front view over here for the first angle projection, if we have the front view looking from here, it's going to be the same thing for the third angle. If we have the end view for the first angle looking from here, I'm going to have the exact same diagram over here for the third angle projection. Guys, the diagrams, the 2D diagrams for both the first angle and the third angle views remain exactly the same. Same views, same dimensions, same everything. The only thing that changes is the position. For example, if in first angle we had the front over here, now it's going to be over here. That is it. The views will remain the same and the dimensions will remain the same. So, if we have the front view, this is first angle, like I said, front view, end view, plan, 45-degree mitre line. The front view is when we're looking from here. So when we're looking from here, what we can see is this, 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 and this. So that is what I draw over here. I read the dimensions from the 3D block and I place them on a 2D diagram. For the end view, I'd be looking from here. So what I would see is this. Yeah? And I would draw that over here. Now take note that the front view and end view, the vertical sides, are both the same. Then you draw out the 45-degree line and you draw the plan. Now the plan is what we see from the top. So it's this, 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 and this. Take their dimensions and place them over here. Okay? Now as you can see, between each view, I have a spacing. That spacing is always 15 millimeters over here and always 15 millimeters over here. Okay? Now, if we go to the third angle, look, the front view is exactly the same as this front view. The end view is exactly the same as this end view. And the plan is exactly the same as this plan. Because, like I said, the views and the dimensions always remain exactly the same. The only thing that happens is with the third angle, front view comes over here, end view comes over here, plan goes over here, and the 45 meter line goes over here. That is the only difference between the two when drawing the views. Okay? Now one more thing. They each have a symbol that represents the first angle and a symbol that represents the third angle. Now, the symbols are the same in the way that they both have this cup and two circles. See? This one also has a cup and two circles. What makes them different is the order that they are drawn in. This one has the cup first, and this one has the circles first. An easy way to remember this is that first angle, number 1, is a straight line. So the symbol is going to begin with a straight line. Third angle, number 3, is a curved number. So the symbol has to begin with a curve. Okay? Now, the dimensions are this over here is 10 millimeters. This over here is 15. This space between here and the center of the circles is 15. Okay? And the space between the first line of the cup and the second line is 15 as well. But you would tell me, but miss, how would I know the radii of the circles? Easy. Now, the center we know where it is because it's in the midpoint of the cup, okay? The first circle, the dimensions is taken to the first line of the cup. So it's 10 millimeters in diameter. Second one is taken to the second line of the cup. So it is 15 millimeters in diameter. Okay? For the third angle, the dimensions remain exactly the same. The only difference is that we put the circles in the beginning. Okay? That's all there is to it. Don't complicate it too much.